In this video, we're going to look at some system problems that are caused by the electrical system and some tips of how to troubleshoot the electrical system. Electrical troubleshooting is not as tough as it looks. You need to have a systematic way to troubleshoot the system and go through each component to find where your problem is. Most modern-day HVAC systems have circuit boards that have lights or LED readouts on them that will give you a code that will tell you exactly what the problem is and what you need to look for to resolve the issue. You need to have a process of working through the system and trying to find the problem. Use a process of elimination. Find out what is working in the system and then focus on what is not working. The first thing that you need to check on any system is the incoming power source to L1, L2. Every HVAC system has a minimum and a maximum power source that is supplied to the unit. Make sure the power coming into the unit is within the parameters that's listed on the data tag. In order to take these electrical readings on an HVAC system, you will need good quality electrical meters to measure voltage and amp draw on a system. As we stated, you want to take your voltmeter to check the power source to make sure that the correct voltage is being supplied to the unit. The next step would then be to make sure that the correct voltage is being supplied to the component that is not working. If you have voltage being supplied to a motor, for example, and the motor is not running, the problem is most likely that the motor is bad and is not able to turn or run with the voltage applied to it. With a voltmeter, we want to make sure that the proper voltage is being supplied to each leg of the motor. And you also want to check for voltage unbalance, which is a maximum of 2%, and current unbalance, which is a maximum of 10%. Exceeding these limits will cause the motor to run hot and will result in motor failure. With an amp meter, which is a clamp-on type meter, we can read the amp draw to a motor or a device on the system to make sure that it's drawing the proper current designed for that system and for that device. All motors and components that draw current in a system will have an amp draw listed on it as to the current amp draw that should be for that device. Checking with an amp meter to make sure that the motor is running within its design parameters is a part of troubleshooting the system. Ohm readings are taken with the power on the system turned off so that we can check wires and certain devices to make sure that they are operating correctly. In this particular example, we are seeing a short or no resistance across a closed switch. In this particular example, we're seeing an open circuit. The coil on this device is open, and so therefore a contactor or relay will not be energized because the circuit is open. In this example, we are measuring a measurable resistance across the coil, which would be normal. Sometimes the resistance value is given to you on certain devices, and if it's within the range as designed, that's good. If you're exceeding that range, it could be because the wires are breaking down in that coil and the device is failing. In most troubleshooting guides, you will see this warning to not use an ohm meter to test solid-state circuits unless indicated by the manufacturer. This is because the ohm meter uses a battery to put a voltage out through the circuit to test it, and some solid-state devices cannot take those electrical charges. So check with your manufacturer and your troubleshooting guide before you make ohm readings on solid-state circuit boards. When an electrical circuit is not working, one of the most common methods of troubleshooting that circuit would be the hopscotch method. This is taking your voltmeter and starting at the source and hopscotch or jumping across each device to find out where you're losing the voltage to the relay or the motor or whatever device you're trying to energize. Another tip, when you're troubleshooting safety devices on a furnace or, for that matter, any heat pump or air conditioner, Normally, you will check across the safety device to make sure that it's either open or closed, whatever state it's supposed to be in. But many times we have techs tell us they have checked the switch and it's closed, but the furnace or the heat pump is still not running. Usually we direct the technician to jumper that safety circuit at the board where the circuit goes into the board. What this will do is eliminate the wiring and any plugs that are in that circuit. The switch itself may be closed, but the circuit may be open due to a broken wire or a pin in a plug that's not making contact. Here's another example where we're checking a flame rollout switch to make sure that it's closed so that the furnace will operate, and we find the switch is closed, but the furnace will still not operate. So here again we would direct the technician to jumper the flame circuit at the board to eliminate the wiring and the plugs. This would eliminate anything out in that circuit, and if it works by jumpering at the board, then we know that a plug or a wire is defective in that circuit.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.